Katainen architecture welcomes you. The ask was to use AI, especially generative AI, in solving 3 business issues for an electric vehicle rental company. Our approach was to first look at the whole system architecture, where AI can have impact, and finally focus on the key problems. Top-level architecture's one diagram. Connections are always started by devices for security reasons. They send data to an agent on backend consisting of protocol and common path. Agent validates and changes data to a canonical format before putting it to a message queue or PubSub service. Interested applications can read it from there. Data requiring fast response is immediately handled. All data is stored to a data warehouse. Data in warehouse is used with different business and management applications along their own data. Some of these applications, such as charging and feed force, are domains of their own with complex structure. Actions towards devices such as purchase-based activations flow in the opposite direction, finally to a drop-off table waiting for the next connection from the device when they finally get fetched. Whole architecture wasn't probably in the ask, but I like it to discover unclear topics. Should, for example, feed force vans be managed by same backend, or does the additional complexity eat all benefits? Should the process be boss-led with dispatch manager handling out work orders, or should teams be empowered to pick open tasks? This is a cultural question, and we have both in Europe. These with many friends need to be answered as you start the work. Finally, some AI. Predictive models follow the same basic architecture. We start with captured values, calculate new features from them, run training pipelines splitting data to train, validate, and iterating until target accuracy is reached. Then we use the model to create predictions in advance and store them to an in-memory cache so that users get immediate responses. When something actually happens, we have realized value and we can compare it to the predicted value. And we can follow the model drift and decide when there is a need to renew the model. We calculate predictive models for all components that we are interested in. Predicting customer demand uses same architecture just with different data. Demand predictions can then be useful for dynamic pricing and in marketing, for example. Adding GPUs to vehicles enables inference there, saving company a few bobs. Now predictions flow with the rest of the data and finally find their way to the in-memory cache. Rest of the system architecture works as before. Customer behavior models are based on purchase data that is enriched with calculated fields like time to next purchase. First, we segment customers with algorithms like k-means. These calculate the number of clusters and attach to each customer the cluster ID. We enriched all customer data with cluster ID to enable training models for each customer segment. Marketing can then start testing how to convert ad hoc users to daily commuters. Easy first step is to target already frequent customers. With additional user data, the segmenting can be redone. Chatbots are most common generative AI use case today. They help customers to ask questions on topics like available range or to ask for personal offers. They can be implemented as a simple pipeline with guardrails, asking first LLM what additional info we need, then using functions to gather additional context, and finally passing all to the LLM that formulates the final answer. Passed again via guardrails before shown to user. Chatbot in Operations Center is more powerful as it allows to make changes to the system. We need human supervision. It can work so that LLM makes a plan that is returned to the user for approval, rejections, or editing, and finally submit for execution. This can be extended so that the whole ops team can work on pending plans. To incentivize, rewards can be given for successful edits. Always room for improvement. I was planning to use BMAD method agent as the second iteration team, but ran out of time. Also wanted to rename for reasons, but was unable. Plus completely missed a few key areas. And that's Katainen done and dusted. Thank you.